All right, I'm back with chapter 2 outline. So just a refresher, as I'm going through this, you're going to fill this out, pause as needed, and bring it to class with you next week. So density curve. There's two characteristics that has to exist on or above the x-axis because probabilities are only positive or 0 up to 1, and the area underneath has to be 1. The sum of all the probabilities has to be 1. So there's a symmetric density curve. The mean and median would be equal. Skewed to the left, the mean is less than the median, and skewed right, the mean is greater than the median. The mean is the balance point. If I were to put this on a balance, it's where it would balance. And the median is the equal area point. Equal area point. We talked about the 68, 95, 99.7 rule for normal distribution. That's not something we really used much because we did normal CDF to get the area under the curve. Percentile is the percent of the values that are less than or equal to a given number. So if you score an 80 on a test, like what percent of the class had a score of less than or equal to 80? If it's 80%, if it's let's say 60%, then you're at the 60th percentile. When you add a constant to all the values in a data set, the mean and the median, this is just a shift. That's all this is. The mean and the median, measures of center, change. Measures of variability do not. When you multiply, this we called a rescale. Measures of center change, measures of variability also change. The variance I put in here, because this is the standard deviation squared, it would change by the rescale squared. Standardizing, it's just subtract the mean, divide by the standard deviation. That's your z-score formula. What does the z-score tell us? It's the number of standard deviations a data point is above or below the mean. Why do we do this? Because we want to be able to find area under the curve and compare maybe two separate things. Moving on. So if we take a random sample of AP scores from last year, this is not my class. Let me make that very clear. We plug these into a calculator, list one. We run one variable statistics. If I'm trying to determine if data is approximately normal, I can look at the histogram. I can compare the mean and median once I have the one variable statistics, and that will help me get a sense of, is the data bell-shaped? Is it unimodal, roughly symmetric, centered around some value? One other thing we talked about in chapter 2, other than like using inverse norm, normal CDF, is a cumulative relative frequency graph. And this is a fancy word for a way to say it's a percentile graph. So on the x-axis, it's really, the vertical axis is really just percentile. So if I take these AP scores, a regular histogram would look like this. AP score, frequency, this is unimodal, roughly symmetric. And I create this cumulative relative frequency graph. Here are the percentages. I just made them out of fractions. So one person scored a 1. 3 people scored a 2. So overall, I have 4 people cumulative. 7 people scored a 3. So the 4 plus the 7, I'm up to 11. 2 people scored a 4. So I bumped to 13. And 1 scored a 5. I bumped to 15. So I'm going to eventually have 100% of the data. This is just going to continue to increase. If you have a flat section, then there's no data there. They could ask you to find IQR, quartiles. Based on this, are there any outliers? The quartiles would be the 75th percentile, the 25th percentile. The median would be like the 50th percentile. So if I was doing it here, that would hit at 3. So the median would be 3. The 25th percentile, whatever 25% of 14 is, I'm going to look at that and see where that is. So that is chapter 2. Quick summary on that. This is all about exploring data.